Hey there. In the last video, we created an agent in one line of code using Fubara's AgentBackedCommand gem. In this video, I want to split it into two AgentBackedCommands and flesh out their inputs, their result types, their dependencies, and then share with you some epiphanies I've had while thinking about this stuff lately. Here we have the ReviewAllLoanFiles AgentBackedCommand. We are exposing it on the command line. We ran it with this verbose option so that we could see which decisions it's making. We can see that it decided to deny this loan file due to insufficient pay stubs and that it used the correct credit score. In fact, this is all the correct expected data. You can check out the last video if you are particularly interested in the data itself. But in this video, I want to split this up into two commands. So let's do that. So I want a ReviewAllLoanFiles command and a ReviewLoanFile command. So we will have one depend on the other. And let's add a description, which might help the LLM make good decisions, especially if it's a smaller model. And now I want to copy over a bunch of other commands that I can depend on. I'm going to copy them from this file. Paste them in here, clean them up. And I want 4 of them for ReviewLoanFile to depend on. And it's these last 4. Okay. And ReviewAllLoanFile will depend on these other 2. So let's give ReviewLoanFile an inputs type. It needs a loan file. And let's give it a result of an underwriter decision. For ReviewAllLoanFiles, I want to give it a result type of an array that includes the applicant name and the underwriter decision. Underwriting decision? Underwriter decision. Let's call it decision. And we can go ahead and set the LLM model that we want to use. I'll set it to QN3 or Quen3. I do not know how to pronounce this. I should figure that out. And let's make it verbose. And we'll make this one verbose. Now I want to test out this result type programmatically. So I'm not going to expose it on the command line anymore. Instead, I'm just going to call the command directly. And let's unpack the applicant name and decision. And we can call denied on the decision because it's a proper underwriting decision model. So let's print out the applicant name and the denied reasons. And we can use denied reasons programmatically as well, even though this came from an LLM. Let's put some white space here to make the output stand out, and let's add some error handling. We'll just print the errors out. Okay, let's run this. First, I need to create the demo loan files so that I can review them again. And we can see the outer command using QN3, Quen3. And there it is calling the inner command, which defaults to 3.7 Sonnet. And we can see it passing a loan file of 4. See it denying a loan file here. For the expected reason, low credit score, and it used the correct credit score of 650, which is the median. And here we see Basil being denied for insufficient pay stubs as expected. And Fumiko approved. So that all worked. And here's our output, our programmatic output. So this here worked. We were able to get proper models out of our AgentBackedCommands without having to write any domain logic, meaning we didn't have to write execute methods. Now, something that makes me nervous is we are passing this entire loan file to the ReviewAllLoanFile command. Perhaps the LLM making this credit decision is biased. Maybe it'd be biased by the applicant's name, which is totally irrelevant to making this credit decision. So instead of passing the whole loan file, I'm going to pass it just the information that I know it needs to review the loan file. So I'm going to create a new model called Underwriter Summary. I'm going to give it a loan file ID because I know it needs it for approve loan file and deny loan file. It needs a credit policy. It needs to know how many pay stubs there are. What else? The FICO scores. So we'll pass a triple of FICO scores. We can express that like this in Fubara. And now we can use this as our inputs. And I'm going to go ahead and remove Blend 3 here. Okay. So here we can see that it actually passed in those triple of FICO scores and really the whole underwriter summary. And we can see, again, it's making the expected decisions. Oh, it made an error here and looks like it's recovered from it. That's interesting. Okay, so Basil is in the expected state. And Fumiko is in the expected state. And we got our output again. So even though I changed the interface to review loan file, I did not have to change any domain logic inside review loan file. And more interestingly, I didn't have to change any domain logic inside of review all loan files, which depends on it. So before we get to the resulting epiphanies, I want to look at this in a diagram format, what we just did here. These are the models. These are not interesting at the moment, but you can pause the video if you want to see them. Here are all of the commands we wrote in the loan origination domain. In the last video, we added ReviewAllLoanFiles, which was able to operate the entire loan origination domain to get its job done. In this video, we've made it depend explicitly on two other commands, one of them also being an agent-backed command. And I want to just zoom in on that part of the domain right now and talk about this relationship here. So something that was interesting here is that even though we changed the interface of review loan file, we did not have to change domain logic inside a review loan file. Normally, we would have to update the logic in review loan file because now, instead of digging out the data we need from the loan file, we have to dig it out of the underwriter summary. So we've broken the code in review loan file by changing the interface to review loan file. That's not so surprising. It is kind of surprising that we don't actually have to fix any domain logic. What's even more surprising is we also should have needed to fix domain logic in review all loan files because we broke the contract between these two commands, but we did not have to do that. And this is not unique to only this relationship. If we were to have changed this relationship instead, we would have to fix the domain logic and find a loan file that needs review because it actually does contain domain logic. but review all loan files would not have to be changed at all just because we changed the interface to find a loan file that needs review. So that is interesting. And let's contrast that to this relationship here between these two commands. You could pick any two commands that have a dependency. But if we change the interface to start loan application, not only do we have to fix the code in start loan application, the domain logic implementation inside start loan application, we have to fix the domain logic implementation in prepare loan file records as well. And sometimes we don't control the calling code or even know of the existence of the calling code. So it's pretty cool over here that in this relationship, I can actually change review loan file without breaking review all loan files. And I could also even just completely remove it and make review all loan files depend on these 5 files. I would have to change the explicit dependencies in review all loan files unless we went back to the approach in the last video where it could operate the whole domain. But regardless, I could remove review loan file entirely without breaking review all loan files, not just changing its interface. So now I want to talk about 2 epiphanies that I've come to thinking about this stuff. The first is that the previous mental model I had was that when you change a code unit's public interface, you might break it itself and all code units that call it. My new mental model is changing a code unit's public interface might break it if it contains domain logic implementation and all code units that call it that contain domain logic implementation themselves. So it's the same mental model, but with this basic qualifier added. And another way to state that is just simply domain logic implementation couples code, which is something I had never really thought about before. And less domain logic implementation means less coupling as a result of that. To put it in more Fubara-ish terms, if a command has no execute method, then it is not coupled to its own interface. And if a command has no execute method, then it is not coupled to the interfaces of the subcommands that it runs. So the second epiphany that I've had thinking about this is that code units whose domain logic has been abstracted away, such as AgentBackedCommands, they can be used to fill in gaps in a domain's implementation in a flexible, decoupled way. So maybe there's a future where early on, we use LLMs to avoid domain logic implementation while prototyping. And then later, as the business scales and the domain becomes better known, we replace the LLM automated parts with actual domain logic implementation. And this is interesting to me because it's counterintuitive. We're deautomating as we go instead of automating. And the reason this happens is that by using the LLMs to avoid domain logic implementation, we get increased decoupling and flexibility and reduced risk of hardening a bad mental model, hardening bad interfaces early on. But then as the business matures, we might care more about reducing cost, increasing speed, increasing accuracy. These might be more important. And at that point, we might have a better idea of which interfaces we would like to use. And yeah, that's it. I'll probably make another video going through the code to just show how it works because it's kind of interesting. Yeah, thanks again. Take care. Peace.